Dear students, you are familiar with different tastes like sour, sweet, saline, and bitter. The substances which taste sour are called acids. The substances with bitter tastes are called bases. Some fruits like vinegar contain acetic acid. Lemon contains citric acid, and unripe grapes contain tartaric acid. Arrhenius theory of acid. A substance which has replaceable hydrogen atom is called acid. Here you can see in animation when a few drops of hydrochloric acid is added in the test tube containing water, hydrochloric ionized into hydronium ions and chloride ions. This solution behaves like an acid due to the availability of hydronium ions in water. Similarly, experiment performed with nitric acid and sulfuric acid. Nitric acid ionizes into hydronium and nitrate ions. Sulfuric acid ionizes into hydronium ion and sulfate ions, and phosphoric acid ionizes into hydronium ions and phosphate ions.
Acids are classified on the basis of number of protons produced per molecule of acid. Monoprotic acid, like hydrochloric acid, it produces one proton. Diprotic acid, like sulfuric acid, it produces two proton. Triprotic, like phosphoric acid, it produces three proton.
Click on uses of each acid to see their images. An acid which is almost completely ionized in water is known as strong acid. Here you can see in this animation when hydrochloric acid is dissolved in water, it completely ionizes in hydronium ions and chloride ions in per unit volume of solution, and no hydrochloric molecules remain in the water. That is, all are dissociated. Acids which are partially ionized in water are known as weak acids. Acetic acid partially ionizes in hydronium cation and acetate anions, and there is some amount of acidic molecules remaining in the unionized form in the water as shown here. When litmus solution is added in base, it turns colorless to blue color, and in acidic medium, it turns colorless to red color. When methyl orange indicator is added in base, it turns colorless to yellow color, and in acidic medium, it turns colorless to red color. Phenolphthalein indicator turns pink color in basic medium. Indicator is a chemical substance which has different color in acid or base medium. There are two types of indicators, natural and synthetic. Natural indicators are petunia and geranium petals, turmeric powder, and red cabbage leaves. Take extract of red cabbage. Add a few drops of acid and base solutions respectively. You will notice that basic solution turns it blue,
and in acidic medium it turns to red color.
Similarly, turmeric solution turns to brown in basic medium,
and in acidic medium it turns to yellow color.
Take blue litmus, red litmus, methyl orange. Now, add a few drops of acid to each solution one by one. You will notice the change in the colors. All acids turn blue litmus solution red and methyl orange solution yellow to red. Reaction of zinc with sulfuric acid is shown by this activity. Take a few pieces of granulated zinc in a conical flask and add 20 ml of dilute sulfuric acid. A gas evolves. Now, close the mouth of conical flask with a cork fitted with delivery tube. Put the other end of the delivery tube in the flask containing soap solution. The gas comes out in the form of bubbles. Now, bring a burning matchstick. It burns with pop sound. It shows that acids react with metals producing hydrogen gas. Reaction of metal oxide with acid may be illustrated with this activity. Take some amount of copper oxide. Notice its color. It is black. Add 20 ml of dilute hydrochloric acid and note its color. It is colorless. Stir the solution with spatula. The color of solution appears blue-green. It is due to formation of copper chloride. Now, add sulfuric acid in blue-green solution. It becomes blue due to formation of copper sulfate.
Reactions of acids with water. Take 20 milliliter water in a beaker. Place thermometer in it and note the temperature of water. Now add 5 milliliter of concentrate sulfuric acid to it and temperature rises. Acids, when mixed with water, heat is evolved. Such reactions are called exothermic reactions.
Take 2 hard glass test tubes and put small quantity of solid sodium carbonate and sodium bicarbonate in each test tube. Mark them as X and Y. Close the mouth of each test tube with cork fitted with the funnel and delivery tubes. Now, add 5 ml of dilute hydrochloric acid to each test tube. The acid reacts vigorously and brisk effervescence is observed in both. It is identified as carbon dioxide. When gas is passed through a solution of lime water, it turns milky in both test tubes. It shows that both carbonate and bicarbonate give carbon dioxide. Neutralization can be explained in this way. Take 5 ml of hydrochloric acid solution. Add some sodium hydroxide solution to it drop by drop. The solution becomes neutral. It can be represented by ionic equation as acid gives hydrogen ion and base gives hydroxide ion. Hydrogen ion reacts with hydroxide ion to give water. This is neutral.
Let us perform an activity to know whether all compounds containing hydrogen are acidic or not. Click any one of the compounds given here. HCl. Hydrochloric furnishes hydronium ion and chloride ion in per unit volume of solution and conducts electricity. H2SO4. Sulfuric acid. Sulfuric acid furnishes hydronium ion and conducts electricity. Glucose. Glucose does not conduct electricity because they cannot dissociate in ions form. Alcohols. Alcohol does not conduct electricity because they cannot furnish in ions in the solution.
Acids give hydronium ion in aqueous solution. It is explained by this activity. Take some sodium chloride in a test tube. Add 2 ml concentrated sulfuric acid. Close the mouth of test tube with a cork fitted with a delivery tube containing anhydrous calcium chloride. Bring the dry blue litmus paper at the end of the delivery tube. No change occurs in litmus paper. Remove the litmus paper. Now, bring a moist blue litmus paper. Its color turns to red. We conclude that acids give hydronium ion in water.